I'd like to talk a little bit about the function natural log of x. So, the natural log function is just a logarithmic function base e. Okay, so what I mean by that is ln x is the same thing as log base e of x. Okay, it's just used so commonly that it gets its own special name, natural log of x. So that's all this is really, is that. So there's just a few properties I want to share here, and a lot of these are true. These first four here are all true for any logarithmic function, but specifically also natural log. And first off, very, very important that we know this. Natural log of 1 is equal to 0. Okay, natural log of 1 is equal to 0. That's something you're expected to know without a calculator. And again, you know, the log base e of 1, that's what that means. So basically this means, you know, e to the what is equal to 1. So, you know, any number to the 0 exponent is equal to 1, so that's why natural log of 1 is equal to 0. So that right there is something we got to know. Okay, you're expected to know that without a calculator. Another thing is that log of a times b is equal to ln a plus ln b. Okay, so that right there is something that can come in useful at times. Something else here is that natural log of a to the n, or a to the, you know, any constant, or is equal to n times natural log of a. Okay, so you can just take that exponent and bring it down. And another one right here is natural log of a over b is equal to natural log of a minus natural log of b. Now these will come in handy as we work with functions at times, but you know, something where I could use this, for instance, to what's called expand out a natural log function, which sometimes will make it easier to find the derivative of, would be an example something like this. So say I had like y equals natural log of x squared sine of x. So once we get into taking the derivatives, you'll see how simplifying this first, or expanding this out first, makes it easier to find the derivative. So first off, let me apply this rule to it right here. Think of like the x squared is a, and the sine of x is b. And what I can do is then break it up like this. So I have y is equal to natural log of x squared plus natural log sine of x. So I can break it up like that. And then I can even go further right here. Notice, okay, well here I have, you know, a to the n. This is like, you know, the a, that's like the n. I could bring the 2 down in front of the natural log and write it as y equals 2 natural log x plus natural log sine of x. So, you know, that's a way to expand this out. Okay. Now, something that this is actually used quite often, probably more so in Calc BC, but is used quite often to simplify answers. So let's say you have something like natural log of, oh, I don't know, x, you know, plus 2 minus natural log of x minus 3, let's say, for instance. Okay? And you have that. What you could do is you could think, you know, this right here currently is in like this form right here, where a would be like the x plus 2 and b would be like the x minus 3, and you could go backwards and rewrite it like that. So you could rewrite it as natural log of x plus 2 over x minus 3. Like there are times where this might be the answer that you get as you work it out, but it's a multiple choice question, but they have the answer written like this. So you have to recognize that those are the same thing actually. So that is definitely important to know how to use that. Another thing that is important is knowing what the graph of natural log x looks like. Okay, you don't have to know exact details on what every value is, but we do know that when x is 1, okay, natural log is equal to 0. So it goes through that point, you know, 1, 0 right there, and it looks basically generally like this. So this is the graph of natural log x. I should probably kind of like maybe like that. Okay. So that is the natural log x graph. Now again, it's in your best interest to, I guess, memorize that graph to know what it looks like, because there's times, especially when you ask about limits of things and so forth, that you'll need to know what that graph looks like. Like for instance, if you were asked something about the limit as x approaches infinity of natural log x, remember this means as x goes to infinity, what is happening to the y value? And as x goes to infinity, although this does grow slowly, it continues to grow forever. And therefore the limit does go to infinity. So this limit, it would be acceptable to put either infinity or does not exist, because we should know that if the limit goes to infinity, it means it doesn't exist. It doesn't actually go to a certain y value. And another common thing is to be asked about the limit as x approaches 0 from the right-hand side of natural log of x. And as I look, here's x equals 0. I'm only looking as it's approaching from the right-hand side because of that positive sign right there. So as x approaches 0 from the right-hand side, it looks like my y value just keeps getting smaller and smaller and smaller and smaller, going down to negative infinity, which again is the same thing as does not exist. Okay. So there's just some basic information that you should know about natural log of x.